Hi guys, so for today's lesson, get rid of that. For today's lesson, we're dealing with operations with surds. So last lesson, we kind of introduced surds and what they are. So surds are pretty much just numbers that contain like a root sign. So here we've got the square root of 3. That doesn't simplify. So therefore we keep it looking like that. And that's what we call a surd. A surd is also something like this. So 5 lots of that square root of 3. So you can have numbers out the front that are multiplying. Okay, so now the first thing we want to look at is like surds. So like surds are pretty much surds that have exactly the same number underneath the root sign. So here I've got root 3 and here I've got root 3. So that means that they're like surds. Simple as that. And down here we got root 7 and root 6. Now they're different numbers, so therefore they're unlike surds. They got to be the same number. So that's pretty much the basic concept. The reason why I want to talk to you about like surds is because when you're adding and subtracting surds, you can only add and subtract like surds. They have to be like. So you can only add and subtract when the surds have the same, you have the same number under the square root sign. Okay, so let's do an example of this. So here we've got root 3. And here we've got 5 root 3. These two are like surds, so we can add them together. So the idea is that root 3 is the same as one lot of root 3, 1 root 3. So that's just one lot of root 3. You don't need to show that one. And one lot of root 3 plus 5 lots of root 3, well, one lot plus 5 lots is going to give you 6 lots of root 3. So the idea is you add the 1 and the 5 to make 6, but the surd number does not change. So simple as that. Final answer. So we could combine these to make that. Okay, next one. We've got 2 lots of root 7 and taking away 8 lots of root 7. So those two are like surds, but this one is unlike, so it has to stay separate. Okay, so 2 lots take away 8 lots. That gets you negative 6 lots of root 7. And then the minus 5 lots of root 2, well, that's unlike, so you have to keep these separate. So there's your final answer that's circled. Simple as that. Okay, well, so we've done adding and subtracting. What about multiplying? So what do we do? When we're multiplying, you can multiply any surds together. So they don't have to be like anymore. They can be unlike. What you do is you multiply the normal numbers together and you also multiply the surd numbers together. So you have to keep the normal numbers and the surd numbers separate. So an example is this. So the 2 and the 7, they're our normal numbers. They multiply to give 14. That goes out the front. And then our surd numbers, 10 and 3, they multiply together and they become our surd part of our answer. And these two parts literally just go next to each other. So it's as simple as that. With example 2, we've got surds multiplying with normal numbers, which are multiplying by another surd. So the idea is that our surds go together. So root 3 and root 12 make our root 36, and our normal number 2 has to go in front. So you can't combine the normal numbers and the surds, so it stays like that. So there's your final answer. Oh, hang on, but the square root of 36, that simplifies. The square root of 36 is 6. So change it if you can. So you've got to be careful and look out for square numbers. Think each time you make a square root, can you square root it? Here, the square root of 30, you can't square root 30, so you keep it like that. But here, we can change it to a 6. So 2 times 6 makes our final answer of 12. So next up, division. So when we're dividing surds, what do we do? Well, you can divide any surds together. They don't have to be like, but you need to make a fraction first. So make your typical fraction when you're dividing. So we got to simplify the normal numbers together, and you simplify the surd numbers. So it's similar to multiplication, but instead of multiplying, you're dividing. So let's give that a try. So with this example here, we've got our 14 and our 7. They're our normal numbers. Put them into a fraction. That's going to simplify to 2 over 1. So that's going to be part of your final answer. And then we've got the root 6 and the root 15. So they go on top of each other like that. And 6 over 15 simplifies to 2 over 5. And so that's going to be part of your answer. Now notice the 2 and the 5 I kept in the square root signs. Really important that you keep them as surds. These were originally surd numbers, so they're going to stay surd numbers. Okay, so then we get to this stage right here. So 2 over 1 and then root 2 over root 5. Well, 2 lots of root 2, that has to stay put, but 1 lot of root 5, that's just the same as root 5. You don't need to show this 1. So important that you simplify these answers, so that's as simple as it gets. So 2 root 2 over root 5. The next example is this one here, very similar. So the 5 over 15, that makes 1 over 3. And the 20 over 10, well, that's going to be 2 over 1. Now, there's just a few little extra bits to simplify it. So when you get to this stage, so 1 over 3 and 2 over 1, you got to think to yourself, well, 1 root 2, that's the same as just root 2. And 3 lots of root 1. Well, root 1 is the same as 1 because the square root of 1 is 1. So 3 times root 1 is just 3 times 1, which equals 3. So therefore, your bottom denominator, all this, just changes to a normal 3. So there's your final answer right there. Okay, so hopefully this is giving you all the tools you need to be able to deal with some of the homework questions. The textbook questions. Good luck. Let me know if there's any concerns. Bye.